we discussed in some detail ways of measuring precipitation at a point, but this is a fairly limited set of observations. We actually have very sparse networks of precipitation gauges, and there's almost none over the oceans. So this raises the question, how do we measure precipitation at much larger spatial scales? And to do this, we rely on areal or area-based methods. And in particular, we rely on the fact that microwaves, or light at a particular frequency, in the 1 to 10 centimeter wavelength band, tend to be reflected when they encounter raindrops or by snowflakes. And because of this, we have built as a consequence a number of ground-based radar stations. So here's some radar station. It's got a big antenna that can swivel around, that can emit microwaves, and when they hit a cloud, when they hit water in the atmosphere, they will tend to be backscattered and they will return. And the idea is that the intensity of this backscatter can be directly related to the amount of rain or snow that's happening right here. So it provides an instantaneous snapshot. And because we know the speed of light, we can tell how far away it is. And this thing can map out these large areas. And you've probably seen this, for example, in Doppler radar maps. And as a side note, this was sort of a measurement noise. So the hydrologic signal here was measurement noise in the early days when they were using radar to try to track airplanes. And they kept being annoyed because the weather was messing with their observations. So this is a way to instantaneously measure at large spatial areas. There are very few, again, ground-based systems. And so we also rely on the fact that satellites that are circling the Earth use both passive and actively emitted microwaves to measure precipitation. So the great thing about this is that this is the single best source for global coverage. No other data set or no other method can really provide information about precipitation happening at a global scale as well as these satellites can. However, there are some drawbacks. For example, they have a limited historical record. And they're prone to, again, measurement uncertainty. They can be prone to bias, and they may underestimate very small amounts of rainfall. However, we still need these areal-based methods. So we need to know what areal-based methods, so the need for areal estimates is still large, and so we will still be using these. We need these for estimates of catchment-wide rainfall, for predicting the hydrologic response of catchments. For example, how will we predict floods, for example? And so in our next video, we're going to talk about ways to scale all of the methods that we've talked about to larger spatial areas in order to go from a single point to areal-based estimates at the catchment scale.